Namaskar, it is Alok Singh. Today we will try to understand pharmacokinetics of inhalation anesthetics, that is absorption, distribution, metabolism and excretion of inhalation anesthetics. Let us start our topic, that is the ADME of inhalation anesthetics. Our today's first topic will be about absorption and distribution of these inhalation anesthetics. We all know these inhalation anesthetics are administered into body through respiratory tract as vapor or in gaseous form, and movement of these inhalation anesthetics will depend upon the various factors, and today we will try to understand these factors that affect these all ADME of inhalation anesthetics. Let us start our topic, that is the absorption and distribution of inhalation anesthetics. First point is the absorption and distribution. This absorption and distribution mainly depend upon diffusion process, means these inhalation anesthetics are absorbed and distributed by the diffusion process. We all know diffusion means movement of molecules from higher concentration to the lower concentration. Technically, we can say this diffusion will depend upon partial pressure of inhalation anesthetics. As the partial pressure of inhalation anesthetics will increase, their rate of absorption and distribution or movement of these inhalation anesthetics shall also be increased. We know these inhalation anesthetics enter into respiratory tract, and from the respiratory tract it enter into lungs alveolar space. From lungs alveolar space, these inhalation anesthetics will get absorbed into blood circulation, and with blood circulation these all inhalation anesthetics will get distributed into the various body compartments and central nervous system. Today we will try to understand how these inhalation anesthetics molecules move from the respiratory tract to the various body compartments and central nervous system. Actually, all these steps or all these processes can be studied under three headings, and these are the alveolar wash-in, blood uptake and tissue uptake. Alveolar wash-in means movement of inhalation anesthetics from the respiratory tract into lungs alveoli. Blood uptake means movement of inhalation anesthetics from the lungs alveoli into blood circulation, and tissue uptake means movement of these inhalation anesthetics from the blood circulation into various body compartments or various organs of the body. In this, first topic is the alveolar wash-in, that is movement of inhalation anesthetics from the respiratory tract into alveolar space. These movements of inhalation anesthetics can be categorized into three, or the factors that affect alveolar wash-in can be divided into three groups. Number one, the factors that will increase rate of wash in, means movement of inhalation anesthetics from the respiratory tract into alveolar space. Second one will be factor that hinder or that stop or that decrease rate of movement of these inhalation anesthetics into alveolar space. And last one shall be factors that have no effect on movement of these inhalation anesthetics from the respiratory tract into alveolar space. Let us start first topic, first group, that is the factors that directly increase rate of inhalation anesthetics alveolar wash in, that is rate of movement of inhalation anesthetics from the respiratory tract into lungs alveoli. These factors are lungs functional capacity. If human or if patient lungs is healthy, it has sufficient or high functional capacity. In that condition, the movement of inhalation anesthetic shall be rapid or shall be high. Similarly, if the inhalation anesthetics have high partial pressure, then there will be high rate of alveolar wash in. Means alveolar wash in is directly proportional to the lungs functional capacity and partial pressure of inhalation anesthetics. Second point is the inversely proportional. Means the breathing rate of patient shall be inversely proportional to the rate of alveolar wash in. Means as the rate of breathing or the breathing rate will increase, the alveolar wash in will decrease. Very simple. If patient will respire very fastly, then in that condition inhalation anesthetics will move out from the respiratory tract through the exhaled gases. And last point is factors that have no effect on alveolar wash in. These are the physical properties of inhalation anesthetics. Inhalation anesthetics physical properties will not affect rate of alveolar wash in. So, first point, we understand what is the alveolar wash in. Now we will try to understand about the blood uptake. Blood uptake means movement of inhalation anesthetics from the alveolar space to the into the blood circulation. This blood uptake will depend upon the solubility of inhalation anesthetics in blood. Very simple. If inhalation anesthetics are highly soluble, then its movement or its absorption from the alveolar space into blood circulation shall also be higher. This solubility can be expressed by the word that is the blood partition coefficient. Blood partition coefficient of inhalation anesthetics. Blood partition coefficient means the drug inhalation anesthetics have low blood partition coefficient. It means that inhalation anesthetics shall easily enter into the blood. For example, there is nitrous oxide. Nitrous oxide has low blood partition coefficient, that is 0.47. It means nitrous oxide shall easily enter into the blood circulation and it will have a high rate of absorption. Second example is the halothane that has high blood gas partition coefficient. If any inhalation anesthetic that has high blood gas partition coefficient means these inhalation anesthetics shall not enter into blood very easily. It means they have poor absorption into blood, and when they enter into blood, they will remain inside blood for the longer duration. It means if they remain in blood for the longer duration, so this inhalation anesthetic will have increased recovery time, means patient will not easily get rid of anesthetic effect of this inhalation anesthetic. There shall be slow change in depth of anesthesia because these inhalation anesthetics remain inside blood for the longer duration. We will conclude, we will try to again try to understand this point. If blood partition coefficient is low, it means drug will enter very slowly into the blood and it will have high induction period. High induction period or increased induction time. But once if drug enter into blood, it will remain inside blood for the longer duration. It means there will be increase in recovery time and there will be slow change in depth of anesthesia. So we understand 2 points. Number 1 is the alveolar wash in and number 2 is the blood uptake. Now we will try to understand third factor, that is the tissue uptake. Tissue uptake means movement of inhalation anesthetics from blood into tissue. This tissue uptake is directly proportional to the tissue capacity of the body to store the inhalation anesthetic. Tissue capacity of the body to store the inhalation anesthetics. Second point is the volume of tissue and third point is tissue blood solubility ratio of inhalation anesthetics. Concentration of these inhalation anesthetics inside human body or inside organ shall be higher in the some organs, some vital organs like brain, heart, liver, kidney and endocrine glands, because these organs have larger size and high blood circulation compared to the other organ of the body. Similarly, some organs have low concentration of inhalation anesthetics and it is the skeletal muscles because it has low blood circulation compared to the brain, heart, liver, kidney and endocrine glands. And at last, some parts like bone, ligaments, cartilage and adipose tissues have very low concentration of the inhalation anesthetics. So these are the factors that affect absorption and distribution of inhalation anesthetics. We will discuss about the metabolism when we will study individual inhalation anesthetics. Now we will come to the last point, that is the excretion of inhalation anesthetics. Excretion of inhalation anesthetics means wash out of inhalation anesthetics. Procedure will be same as it was in the absorption and distribution, but here movement of inhalation anesthetics shall be in opposite direction. Just after a stoppage of inhalation anesthetic administration, or just after discontinuation of inhalation anesthetic administration, the inhalation anesthetics will move out from our body or from our body compartments to the blood, and from blood to the alveolar space, and at last from the alveolar space to the exhaled gases. And this movement will also be affected by the diffusion method, or by the partial pressure, or by the all factors that we have studied in the absorption and distribution, but this movement shall be in the opposite direction. Now we will try to understand these all process, these all ADME through a diagram, and this is here. Inhalation anesthetic will enter into lungs. From lungs it will enter into alveolar space, and from alveolar space it will enter into the arterial blood, means blood circulation. From blood circulation it will get distributed to the various organs like adipose tissues, skeletal muscles, cardiac muscles, brain, and other vital organ of the body like liver, kidney, and heart. We studied that these vital organs like brain, liver, kidney, heart will have a high concentration of the inhalation anesthetics, because the tissues of these organs have high circulation of the blood, means blood are highly circulated, highly perfused in these organs. Similarly, a skeleton has a very low blood circulation, thus in a skeleton its concentration of the inhalation anesthetic shall be very low. Similarly, its concentration in the adipose tissue shall also be very low. I hope I will be able to clarify this subtopic, that is the pharmacokinetics of inhalation anesthetics. If you feel any problem or any doubt, please put your comment in the comment box. I will try to reply your queries or your doubts. Thanks a lot. Thank you very much for viewing this video for such a long duration. Thanks a lot.